Hello. Hello. Yeah. I love people when they interact. They're not like they're alive. I know that they're alive. That's good. Welcome to my talk. I'm going to talk about something that I actually learned earlier this year in Dublin. Is actually in EuroPython. So I did a little bit of things for myself. So I'm going to share the result with you. So before I start, this is probably the most important slides of the whole talk because you don't have to take notes or anything like for the other slides because you got the link to the whole slide, right? So this is probably the most important one because you got the link. And also, I'm still on Twitter-ish because the thing is like Mastodon, I'm also on there, but people can't send me messages, so I'm still on Twitter. That's the only reason why. Right? But if you have questions or if you want to reach out, send me messages, either there or LinkedIn. If you prefer LinkedIn, it's fine. You can find me by my name. So, do you know what is GIL? Or some people pronounce it GIL, but I pronounce it GIL. So just bear with me. If you don't agree, then let's talk after. Yeah. So do you know what that is? You know? Yes. No. You don't have to tell me. Yes. Some people are very confident. Yes, I know, of course. But why are you here? But anyway, so just to make sure everybody's on the same page, I would actually, introduce you about what is GIL in a bit, but before that, I'm Cheuk. I work for Alaconda. That's very important because they pay for my flight ticket here. And also, I work in open source project in the past. So actually, Terminus DB is I worked for them before. They are actually Dublin based. So also, I organize a lot of events. Not this year, Python Global, but I'm speaking there as well. But the one I want to tell you is the one all the way at the right-hand side, that little snake with the head on. That's an online conference, which I'm going to tell you at the end of the talk. So stay tuned. So what is a GIL? For people who are not so sure or haven't put up their hand, that's Global Interpreter Log. That's just GIL, GIL. Or you can call GIL or GIL or whatever. But that's what it means. It's Global Interpreter Logs. But why do we need a log? What is that? Like, what has it to do with Python? So the thing is, so how a computer works is that, so for computer system, we have processes and they are threads. So these things are fancy terms, right? Threads actually like one thing that is like done at a time to something on your computer. You may have heard of like multi-core computer. For example, my very, very old MacBook, which is like, I bought it in 2015, it's very old, is dual core. So, which means that there's two cores. So there's the two thread that's available on the machine. But the thing is, in Python, so Python is a process, it's a program, right? So we don't want multiple threads to be operating Python at the same time. The reason being very straightforward is like if you have two threads that's trying to do something at the same time in Python, it's kind of like two persons trying to drive a car at the same time. There's like you fight over the steering wheel and stuff, so it's a bit messy. So that's why we need logs. Logs is basically trying to like limit that only one thread can have access to an object at the same time. So if you go back to the car, right? So it's only a set of hands from the same person is going to be on the driving wheel at the same time. So you can't have like one person holding a wheel on the left hand and the other person holding the wheel on the right hand. It's like you're fighting it over. No, you can't do that. So imagine like the trouble is that why we can't hold the driving wheel at the same time? Well, because sometimes that person wants to turn left, the other person wants to turn right, then we have a problem, right? So if we have, for example, an object, for example, Python, we have things that's amazing, that's called list. So you can change it, right? It's mutable. So if one thread decided to delete an object in the list and the other try and edit, then so what's in the list right now? I don't know. So it's a bit messy. So for Python solved the problem by having this global interpreter log, which means that we only have one thread that can run all the Python things. You can't have multiple threads that are trying to delete and add something at the same time, especially for these like amazing Python mutable objects. but other programs may have different philosophy, right? They may want to like, okay, it's fine, we have 2 drivers, we just take turn, right? You can, if you have been to a road trip with a friend, then of course if both of you can drive, you can take turn driving. But you just have to figure out a way who is on the driver's seat now. So who is driving now, right? You just need to pass over the ownership of the car. but it's more complicated to do that. So that's why in Python, historically, it's just like we just lock it, right? We just have 1 dedicated driver. That's it. We can't have 2 drivers. So that's how Python deal with it. So then it comes to the question, right? There's people keep asking the question, why we only have 1 dedicated driver for Python? Why we can't have 2? Why we can't have nogil Python? So this nogil Python that I'm talking about is actually a clone of Python 3.9. Now it sounds a bit old because we already have 3.11. But that is a clone of C Python 3.9. And it's actually the 4th attempt. It's not something new. It's not something that one day, someone just like, we actually don't want the GIL. No, it has been attempted multiple times. People, even when was Python was born? Do you know? Anybody know when was Python was born? 1990, yeah. So in 1996, someone's already like thinking, oh, maybe we should not use the GIL. This is the 4th attempt. This version is by Sam Gross. So he was the keynote speaker at EuroPython. That's why I was at his talk. I was like, whoa, mind blown. That's why I want to try it for myself. But they go back to the same point, the original point, right? So far Python has been doing all right. It's popular. It's a very popular language. Why we want to change it, right? Why we want to change this? Why are we moving the GIL? Oh, because you can see that as time went on, there's more and more attempt to try to remove the GIL. The reason being that now we have computers that have multiple cores, and it's very common. Maybe in the 90s, it's like, well, you have to be rich to have a dual-core computer. But now, everybody, like even my old computer have dual-core. Yours may have quad-core, or maybe 8-core, I don't know. So now you have more drivers available. You may want all of them to kind of work at some point. So that would actually help speeding up things as well, because just having 1 thread is kind of like limiting the way of parallel processing all this. So that's why we want the speed. That's the main reason why we want to GIL. So the design and challenges that Sam mentioned, I'm just trying to recap here before I move on to the fun part. So the design of having this new version of Python is that it can't be slow on a single thread. The goal is to make it working well in both single or multiple threads. So it's not just like, oh, this version is for multi-thread, this version is for single thread. No, it's 1 version for all. Also, there's why nogil has been attempted so many times, and there's no final answer to it, and people are still figuring it out because there's a lot of tricky bit when we remove the GIL. For example, the reference counting. Reference counting, is just like how Python keep track of things, how many objects were created and stuff like. If you have multiple threads, if you don't have the GIL, this can be tricky because, an object can be deleted at the time when it's, again, like something can be deleted at the same time can be added. So which one is true? We don't know. So that's why we can't use what we are doing right now for the reference counting. It needs to be something new that's called biased reference counting. I won't go into the detail here, just a recap. So, also there's like a little bit like other very smart trick that was used is that, for example, for some object like true, false, small numbers, small integers, none, those are objects that has been even in like our the C Python version, the normal version, right? Is immortal. So it's object that has been hanging around and then for the life cycle of your program. So it's there. So in this kind of new reference counting kind of changes, we have to make them immortal, which means that we just assume that they're there all the time. There's no reference counting for those objects. And also for some global objects, if you kind of have to keep track of them, it's a bit tricky because they are at the top level. So what this does is that you would defer the reference counting, which add up the counts at the end at the garbage collection. But again, I won't go into the detail, and I'm not very good at talking, telling you all the details. So I will show you the link or the access to the link to check out the original talk. So that's more detail there for you. So there's actually a lot of things that has been, that was on the keynote. So I'm just going to go over all of them. Another challenge that no-GIL version have is the thread safety. So again, objects are mutable. A lot of objects in Python are mutable. So how can we do the thing that's like the dancing of the driver who is driving right now, right? So the small logs need to be introduced again. So now you remove the global interpreter log. So remove the scheme of having one dedicated driver. Now we have to put back the small log to make sure that only one driver at the driving seat at one time. So in the keynote, Sam showed us that there's a way of writing some kind of handover of the log in the CPython code. That's the changes he made to make sure that it got passed over and stuff. So it's super complicated. And so the key thing here is that now Python is using something called PyMalLog. It's the log allocator, but if we're using the new version, this no-GIL version, we're using the MinMalLog, which is developed by the engineers at the Meta. So that's what has been replaced. Also, what they did is to stop the world for garbage collection. So they also, like Sam also mentioned, that during garbage collection, again, all the thread needs to stop, right? Because otherwise someone may be changing something and they're just changing the logic for the garbage collection. So you need to stop the world for the garbage collection. So a long recap of the keynote, which is 45 minutes. So I'm trying to kind of recap them within 10 minutes. So it's very out of breath. But anyway, so let's bring back here. Why am I talking about this? Why I'm doing this? Because there's already a keynote there. It's very informational. Because I want to try something for myself or for data scientists or people who do scientific programming or people like me who do scientific programming. Because I have a question. Does it help? Does this version help? Is it an answer for when we want to make things fast? Because when we have a lot of data, sometimes it's very, very slow. So how can we use that as a very easy fix for this very time-consuming scientific programs? I don't know. So that's why I do this test. The thing is that in a lot of scientific packages like NumPy or scikit-learn, we already use a lot of CPy modules to speed up things. So if you have looked at the source code of NumPy, I don't know why you do it, but you may be curious. So if you look at the source code of NumPy, you see there's a lot of file that's is not .py, right? .py is a Python file. So they have lots of .cpy file. So those files are actually compiled C code that can work with the Python file. So they have all of those to speed things up. And also there's Cython. Cython is a project that is trying to, again, speed up your Python code by taking a chunk of the code and then, compile it, make it into C code to make it faster. So there are lots of different packages and already tricks in the scientific calculation to speed things up. Do we need the no-GIL to make a difference? Do the program will benefit from no-GIL? Does it help? And also, so I want to know. I want to test on some of the thing that I do normally as a data scientist. So I kind of think of how am I going to test it, right? What I'm going to test it on. So I want to try on something that is that I use a lot. For example, scikit-learn. For example, NumPy. Like I said, NumPy got a lot of C module. Does it really help? Also SciPy, SciPy is also something that I use quite a lot. So, also something I want to try. Originally, I want to try on neural network, which PyTorch, TensorFlow, all this. But the problem is that if I want to use no-GIL with PyTorch and and TensorFlow, I need to compile them myself because there are lots of inner working of how it works, and then if I'm using a new version of Python, I have to compile it myself, which I at the end I decided to opt out from doing that. So I've just tried on scikit-learn, NumPy, and SciPy because the nogil compatible version is already available. So that's why I tried those. Also, my test is not very scientific. If you have a better idea of testing it, you can tell me at the end. Last time I gave the talk, actually I gave the talk last week, and then someone was like, oh, you should try profiling it. I was like, okay, maybe, but not right now. Maybe when I have time, when I go home, then I can try profiling it, so I can have a deeper look of why is it slow, why is it fast, and why is it not what I want. Also, how am I going to compare it? I'm going to run, so most of them I'll run it multiple times just to because sometimes, program could have a standard deviation of the speed. So I would have multiple run of that. I would try it on nogil, try it on original 3.9, which is where the nogil version was cloning from, and the 3.11, which is the newest and supposedly fastest Python version. And so all the code that I test, actually most of them are from the documentation site of scikit-learn, NumPy, or SciPy. So I just grabbed them and modified it. So I'm not for example, some of them are plotting graph. I'm not plotting the graph. I'm just testing the speed and stuff. So I'm changing it a little bit, and I put it on GitHub. So if you're curious, you can also go there. Again, this is a link, right? So if you get the link at the beginning of the slides, you can access this slide deck, and then you can go to this link. So this is how you can access all the information hidden in the slide deck. So first test, I do it with the support vector machine. So support vector machine is, so let me explain a little bit if you're not doing scientific programming. So it's just, it's a multi-dimensional array, and we're trying to group data points into different categories. So it's kind of doing some categorization thing. So the example here I use is the one that is from scikit-learn. What they're doing is that they have these handwritten digits that, the black and white picture of the handwritten digit, very low resolution picture. And then with that, they're putting it as a vector in a multi-dimensional, and then try to categorize them with 0, 1, 2, 3, there's 10 category. So they're using this support vector machine, these methods to do it. Normally, it's actually not a very fast process. But anyway, I average it over 50 times. I run 50 times. I hope that it will be faster. So these are the results. So you can see there's not much difference. There's only a slight difference. And even 3.11 is actually not faster than 3.9. So is it me? Sorry. So I believe, I don't know why it's doing this, but so I believe this is just some small deviation, so it's not really significant difference, so there's no improvement. I'll be disappointed, so let's move on. Second test, I do clustering. So again, those digits, those low resolution handwritten 0 to 9 digits, this time we are also trying to categorize them, but instead of using support vector machine, we use other clustering methods like k-mean, which is again we have high dimensional and points and put the vectors in, and we try to use this algorithm called k-mean algorithm to group them together. There are also some other thing called PCA, is kind of vectorization, this crazy math, and random. I actually have to look into what is random, but again, it's a clustering method. So this is the result. So again, you can see there's no difference. Even k-mean is basically to the 3 decimal points after the after 3 digit after decimal point. So it's no difference. So very disappointing. So, but since we are trying to be scientific, well, no, even though I said it's not scientific, but I'm not giving up yet. I'm I still need to find where it got improved. So I'm still trying. This decision tree, so decision tree is an algorithm that, again, you have all this data, and then you try to draw a line and then see if these two are the different, is no, and then make another decision tree, so you combine them to make decisions. I'm very poorly explaining what is decision tree algorithm. But anyway, so this is, I try it again, there's a range of things, so sometimes faster, sometimes smaller, because a lot of decision tree algorithm actually is randomized because it's try join different lines and decisions and combine them at the end, right? Sometimes you got lucky, so it's faster. Sometimes it's not. So, so it's a range of it. So actually, this is not a very good algorithm to test it on. I don't know why I did it, but anyway, this is the result, and you see that actually 3.9 is the fastest. It's the one that I supposed to be the slowest has actually become the fastest, and I'm really puzzled. Again, try more new things like linear algebra. This is the ND array from NumPy. So this one actually, you can see there's an improvement from nogil has an improvement over CPython 3.9, but it's not faster than 3.11. So, so some linear algebra, it seems that there are some improvement, but it's still not the best out of the three. So image filtering, this is, let me quickly explain. So this is applying filters on images. So this is done with NumPy. So because images can be expressed as an array, so as an ND array, so 3-dimensional, or if it's black and white, it's just 1-dimensional, 2D array. So so it's an array. So you can apply some mathematical, filter on it, and then you find edge. Sometimes, like this algorithm, actually, a lot of them are finding the edge of where the boundary is and stuff. So you can see, so for 4 algorithms that I tried, 2 of them, the nogil one is the fastest, but the other 2, the Sobel filter and Canny filter is not the fastest. So this, I think, that's the last one that I test. So MLP classifier, so that's actually a multi-layer perceptron, so it's kind of like a neural network kind of algorithm. So I tried on that one. So it actually involved a lot of like looping, because like neural network, you have to train it over a lot of times. So this is the MLP classifier, and you see that the fastest, again, 5.39. Oh my God, there's no improvement. Very disappointed, right? Like, I think you are as disappointed as me, because you are expecting that, oh, there will be improvement, and yay, everybody's happy. At the end of the talk, everybody go home and happy and use nogil, right? No, this is not that kind of talk. I'm not trying to sell you to use nogil. I'm just trying to discover things and question why it happens, why nogil does not help. So I've made some conclusion myself. You may or may not disagree. Again, we can discuss afterwards. But I think, again, the problem is that because for these, all these libraries that I use, they already have the C extension that was added in. So for a lot of them inside, they already optimize in a lot of ways. For example, the Cython library that I talk about, in Cython, actually you can also remove the GIL. So there's a no-GIL option for Cython. So when you use Cython to speed up, if it's compatible, you already remove the GIL for that small chunk of code. So, it's already been done, like with all these different tools and C extension that we already apply to those libraries. Is that's why there's not much improvement. And also, so those are the C extension that is doing already very optimized, efficient stuff. But there may be other reason why, because those C extension, when they communicate back with Python, they're still expecting the GIL. So it's, there's still one layer of complexity there that the GIL is still supposed to be there. It's not fully removed. Actually, I believe the CPython developers, they had the discussion about that, but of course they are much smarter than me, so I'm not going to, dive into that, but I would show you the link to look into that as well. So for that reason, maybe if in a future version of CPython, I'm not saying that it will happen, but if it happened, then there will be some new design so that there will be APIs or new C API that when a no-GIL extension, when a C extension talk to the Python version, it would know that sometime we're running Python with no GIL. So that's something that is super complicated, and developers need to adopt. And compatibility, so that's the problem. And also, I'm only trying it on a dual-core computer. So like running a multi-threaded code, there's always an overhead. So sometimes if you run it on a lot of cores, you may expect some kind of linear improvement, but there's always overhead. If you compare just one core and 2 cores, you may not see it double, faster or the half of the speed improvement, because the overhead may be heavy. So, if I want to really do a good profiling, I may have to try on multiple cores and then like try to draw a line to see if it's linearly improving. But I only have a dual core, very old laptop here, so can't do that. And also, this no-GIL fork is a very good work done by Sam. He's doing a very good job, but it's still a work in progress, so it's still not the definite answer. And again, there's no plan to remove the GIL in the virtual version of Python yet. So I don't know how it goes, so we'll just keep an eye on this development, and hopefully if it went well, then it will be an improvement for any Python programs, not just the scientific ones. So here are the reference. So that's why I told you to take the picture of the first slide. I will go back to it maybe if you missed the chance. So you will have this slide deck, and you can click on this slide. You can watch the talk by Sam. There will be more information about the design of the no-GIL Python. There's also a blog post by Lukasz. They had the CPython Core Developer Summit back in April, I believe, or May, in the PyCon US. So they had a discussion. So you can also look at the note from him about that discussion of no-GIL Python. They're very informational. If you're really interested, please look at those. And at the end, I promised to tell you about the online conference. So this is PyJamasCon. It's an online conference, and it's free to register your ticket. So it's 2 weeks from now, and there will be talks, there will be fun. People are just like, doing crazy things. So please check it out if you want to. So I think that's the end of my talk. It's like, so it's like 2:30. I do believe there may be a time for a few questions if you have any questions. Well, very enthusiastic question. Okay, I'll let the host, section host, do you want to give the mic? Okay.
And thanks for your talk.
Yeah.
Could you go back to the slide a couple of pages before where you were explaining the reasons you think that you didn't see performance advantage?
Oh, the performance. Okay, sorry. That's at the end. I was trying to go back to the first slide so people can take a picture, but I'll do that after. So this one?
Yeah.
Okay.
Was that? Those are all the reasons? Yeah. Do you have like an instinct for which, like what are the main ones here? If it's C extensions may still be expecting a GIL, how can you find that out from the code? I guess you're not looking at the code, but how would you determine which of these reasons is affecting?
Yeah, these are all my speculations. I won't say that because if you really want to inspect what is the real reason for that, you may have to, like what someone suggested to me last week, that you have to do a more detailed profiling to see what's going on. So again, these are just my speculation, and I think if you ask me now, right, not very scientific, I think that the first reason is the main reason, right? Because I have looked into all the source code of NumPy and all these. They already do a lot of speed up from the C extension, and all the tricks has been done through years. Scikit-learn has adopted a lot of ways of speeding things up and using number, Python, all this try to speed up things. So they're already quite optimized. So there may be still a little room for improvement, but again, the other things are hindering them. If you want to know why, for example, C extension not expecting a GIL, those actually is in the note by Lukasz, so check that one out. The C Python developers was discussing about that, so you can have a detailed look on it if you want to. Yeah.
Right, but my question is more like, at what point do we declare no GIL a failure or a success, or do we expect to see this work in 5 years?
Do I expect what?
When will no GIL actually either show a performance advantage or conclude that we can't?
The answer is I don't know, because right now there's no plan of incorporating this no GIL change in Python. So Python will still have the GIL by default. And also, again, this is 3.9, right? It's clone 3.9. So if it needs to be a candidate to be adopted into Python, it needs to make a rebase of where it should be a clone of the latest version of the CPython. So
sure, but to get to that point, they would need to demonstrate an apples-to-apples comparison on some version of Python of the no-GIL fork. And correct me if I'm wrong, they haven't proven this. It's just this, we have this belief that no-GIL should give us performance advantage, but nobody's proven it.
Right. Can you take that? Yeah, sure.
Sorry.
It becomes a debate now. Amazing.
It's already done, right? Because this is all about C extensions. Just seeing it. So if you really want no-GIL, try like Python, for example.
Can you speak in this one?
Sorry.
The recording.
For example, if you C Python is one Python runtime. There are other ones. There's Jython, there's IronPython, there's PyPy. PyPy, for example, doesn't have a GIL.
PyPy is using the JIT to speed up, right?
Yeah, use a JIT, and there's no concept of GIL in there. The
all existing legacy code does use C extensions. I just want to see this, but here are the C extensions that will
GIL, mostly GIL does not come into effect during C extensions.
Yeah, because it's in C code, so it depends on how you write it, yeah.
As soon as you leave pure Python and cross into extension land, GIL is out of the picture. I assume you were using Anaconda as your distribution?
Sorry?
Were you using Anaconda as your distribution?
Oh no, this is not using Anaconda, no.
Okay, so that'll be the other thing because
this is testing the C, the C. You can find it in, like the C Python and no-GIL version.
The Anaconda ships with all the MKL stuff. Regular stuff doesn't ship with the MKL. That also has an impact on performance on the SciPy libraries.
Yeah, that extra layer to this, I just want it to be a simple experiment.
Yeah, fair enough.
If I add that, that would be like, maybe 10 more slides talking about that as well, so yeah.
I just give you the mic. You just have a
Oh, thanks. Yeah, so what's the main advantage then you'd see for the no-GIL, or the main benefit that it could bring, like, even if it's qualitative at this point? What do you kind of see the value of the project going forward?
Yeah, I won't say it on behalf of Sam, but like if you watch his keynote, he has a better explanation of like why there's no GIL, and like like the thing I think he tested on some generation of Fibonacci numbers, and that's actually a performance improvement for that one. So that's his test. That's the profile that has been done. So that from that we can see, like he said, there's a 10% improvement over the 3.9. So I'm trying something else. I'm trying it on scientific programming just because I want to. So you can see. So that's why like my experiment you can say my experiment failed because there's no improvement. Well, it's an experiment, right? You should not assume anything. So the result of the experiment is that, I don't see much improvement on my machine running on these scientific algorithms, but for him, for what he does, like that, that's an improvement. So, you can't base on this talk and say, no-GIL is useless. No, it's because that's the scientific programming perspective, but Python is not just for scientific programming, so, yeah.
So basically, I get a point that most of the C extension library like Scikit or the NumPy and everything, they already have some speed up in place. Like Scikit is using, I think, joblib or something to parallelize the code. Then won't the better experiment be to actually use pure Python and then test it out using the threadings and all the stuff? Like, why did you choose to go with the Scikit-learn if it's already speed up? Then why will you choose to go with that instead of you writing your own test and testing it out?
Why do I test it on those things that I know that they already have C extenders? Because I want to see if there's extra improvement.
So like basically the Scikit-learn is actually not using GIL at any place. So having a GIL or not GIL won't affect it at all.
There's still a layer of things that is still in most of them, the heavy stuff is already like pushed to the extension stuff, but there's still you're still using it in Python code, right? You're not writing C or Fortran code. So I would see like how the improvement can be if we remove the GIL.
I think then your experiment was successful, right? Like you were seeing speed up at the 10 power minus 3 point. Then I think if GIL is not being used, then your experiment was successful, right? Like you are seeing some improvement then. like not a significant one because it can't be.
Yeah, this is not I would say that if you look at it scientifically, this is not the paper that I published because it's not finished. I should look deeper into like where it got improved. Does it got like different parts of it? But this is just a very quick talk of like having fun. So
it was definitely a great attempt, and yeah, this is a very interesting point in Python. Yeah, definitely.
Yeah.
Thank you.
Any more questions?
So it's more or less what they say. So the first things that I want when I think about nogil, the first experiment that comes in my mind is try to do, for example, something like Mandelbrot fractals with trading. So, and if you do that, I will do this night. Thank you for the inspiration. So probably we'll see some improvement because it's pure Python, and that's concurrent, ideally concurrent. That's the point to say.
Yeah, that's also a point, and you can try it yourself. Try nogil on your algorithms to see if there's improvements.
Are the tests that you run packaged in a way that we can try to run them on any other computer?
Yeah, so this is are you asking where do I put the code, or are you asking like whether you should try?
No, because you have two cores.
The code is on GitHub. So if you take a picture of this, you can use this link to go to the slide and then find it on the GitHub link that I showed you earlier. But I mean, like I encourage everybody to try it. Sam has been very helpful because at some point I was like, oh, it doesn't run like with my scikit-learn. Because I need to recompile, and then he just create one for me. Like he just create a version of SciPy that scikit-learn that works with nogil version for me very quickly. So I think he wants people to try as well. So you can grab it if you go to his nogil user. Also, like if you find, I think if you go on GitHub, you type nogil Python, you will find the thing and exactly the same, and you can.
No, my guess is that we won't see any significant speed up until we get to lots and lots of cores, because the fraction of code that's actually running under the GIL is relatively small because you're using the good Python math libraries.
That could be, but I can't say for sure until I tried it. So
yeah.
We
have to test the hypothesis.
I think we are running out of time, so thank you so much, and we can talk afterwards as well. Thank you.